Hi everybody, today we're going to talk about notes number 4, solving linear equation word problems. And like we had talked about before, if you have any questions, please write in here the time of the video that you have a question of so we can go over it again in class. So the first thing you look at is this tree map of operation alias, the different words or other words that you'd see for addition, subtraction, multiplication, or division. So with addition, you'd have increase by, more than, combined, total of, sum, add or plus, and bring together. Subtraction, you could here see decrease, minus, less than, less, difference of or between, fewer than, take away, subtract. Multiplication would be times, multiply by, product, per, multiple, multiply, double or twice. And division, we look at out of, ratio of, quotient, half, divide. So there are a couple different words that really represent these operations that you'd be able to see in some word problems. So take a minute, pause the video, and you want to make sure you have this tree map listed below. So right below that tree map, I have a couple tips for solving word problems. The first thing you want to do is read the whole problem. So you want to make sure you read the whole problem. Then you want to define what answer you need. So determine what you need, what you're looking for. And you want to not forget that it's units of measure. So if you're looking at feet or inches, what that final answer is represented by. And you want to look for the keywords. This will help you decide what you're actually doing with the problem. Refer to that tree map. And this will help you to identify the operations that are being used. Next, you'd want to reread the problem to be sure that your answer was being asked. And be sure that your answer makes sense. And finally, you want to write your final answer in a sentence. So let's try a couple examples. So here we have 2 examples. And the first one tells us 53 plus times C is as much as 21. So for C. So if we look, it says 53. So numerically, we have 53 plus, which tells us addition, 4 times, which tells us multiplication, the letter C, is as much as or equal to 21. So there we have our equation from our word problem, and now we're just solving for C. So take a minute, try to solve for C, pause the video. And by solving for C, we're going to subtract 53 to both sides, divide by 4, and we get C is -8. For problem 2, call sweatshirts. It costs $65 for the printing plates plus $16 per sweatshirt. If Colin spent $1,249, how many sweatshirts did Colin make? Write an equation and solve. So we know that he was making sweatshirts, so we're going to say that S equals sweatshirts. So I'm identifying what my variable is. It costs $65 just for the plates to print them, plus, which is what I see here, $16 per, when we look back at our table or our tree map and it tells us per represents multiplication. So $16 times the sweatshirts, and he spent a total of $1,249. So here we can subtract 65 to both sides from the equation that we created. So 16s equals 1,184. Divide by 16, and we'd have S equals 74. So that means that Colin made 74 sweatshirts. So Kristen's mother is 58. She is 6 years older than twice Kristen's age. How old is Kristen? So her mother is 58. Kristen is 6 years older, so 6 more than 2 times. So twice is 2 times Kristen's age. For number 4, find 3 consecutive odd integers whose sum is 57. So we're looking for 3 odd integers. So let's say one of the integers is n. So if the odd integer is n, to get to your next odd integer, you have to add 2 numbers. So let's say n is 1. Well, if n is 1, to get to 3, you'd have to add 2. So we could have n plus 2. To the next odd integer, we'd have to add 2 more. So n plus 4. And that's going to equal 57. So here we'd have combining like terms, 3n plus 6 is 57. The next problem, the English alphabet contains 2 more than twice as many letters as the Hawaiian alphabet. How many letters are there in the Hawaiian alphabet? So we know that there are 26 letters in the English alphabet. We're told that it contains 2 more than twice as many as the Hawaiian. So 2 more than 2 times the Hawaiian. Now we can calculate for H. So what I'd like you to do now is I'd like you to find solutions for the variables of 3, 4, and 5. So pause the video and give yourself a minute. So you should get that Kristen is 26 years old. Your 3 odd integers, when you solve for n, you should get that n is 17, which means your 3 odd integers would be 17, 19, 21. And the Hawaiian alphabet, you should have that there are 12 letters in the Hawaiian alphabet. And finally, there are also word problems that include common mathematical formulas. To solve these types of word problems, it helps to find or to first isolate the variable. So a couple examples here. The perimeter of a rectangle equals 40. If the width measures 8 feet, how long is the length? So we know that a perimeter formula is P equals 2L plus 2W. We want to solve for L, so I want to get L all by itself. So to do that, I can subtract 2W from both sides, which would give me P minus 2W equals 2. And then I want to get rid of that 2 by dividing. So I have that L is going to equal P minus 2W divided by 2. Now that I have what L equals, I can find the length of the rectangle by filling in the additional information. So I know that the perimeter, or P, is 40, and the width, or W, is 8. So L equals 40, because that's what the perimeter is, minus 2 times my width, which I'm told is 8, divided by 2. Well, 40 minus 16, 2 times 8 is 16, divided by 2 would give me 12. So the length is 12 feet. So again, I want you to try number 7 all by yourself, so pause the video here. And now you should have solving for R, that R equals D divided by T. And plugging in for rate, you'd have R equals distance of 900 miles over 15 hours. So your rate should be 60 miles per hour. So if you have any questions, I'd like to see that these are completed. And if you have any questions, please make sure that you go back to the front, fill out that time, the timesheet right up here, and I'll go over anything you have questions on.